Hi, I'm John Janeshik from Mirantis, and we're back at KubeCon in Detroit. With me in this next few minutes is Omri Gazitt, who is the CEO and co-founder of Aserto. I heard some great things about Aserto, who have, by the way, an axolotl, a strange amphibious amphibian, as a corporate mascot, about how they are managing access control in a world where our back is becoming too complex for mortals to manage. Tell us, let me hear this from you.
Yeah. So, our story goes back about 15 years where my co-founder and I were at Microsoft, and, things were just getting started in the SaaS world. So companies like, Workday and Salesforce and ServiceNow were, having to invent identity and access on their own. There's no operating system to ask in the cloud who was logged in and what they could do. So they had to go hand roll all that stuff out. And we asked ourselves, what's the equivalent of the directory, of Active Directory in the age of SaaS and cloud? And the answer was, we had to go build it. And so as an industry, we started with identity. So, things like OpenID and OAuth 2 and SAML and JWT, kind of all, were critical in creating what I call the interoperable identity fabric. And you had companies like Okta and Auth0 and OneLogin and PingID that all kind of grew up, building identity for the web, for the SaaS layer. Access control didn't move forward at all. And so, about 2 years ago, my co-founder and I decided we wanted to go after this problem space. So, help access control move to the age of cloud native.
And so, what were the problems that you identified specifically? I spoke about a combinatorial explosion with one of your colleagues earlier, but I think I need that repeated to me so that I really understand it.
So if you think about, how like the IT admin, what their life was, they lived in, one place, LDAP or Active Directory, and they would map users to groups, and those groups represented the roles in business applications.
Right.
And so things were clunky and coarse-grained, but, they were still a lot simpler than they are today. Fast forward to now, an IT admin administers dozens or hundreds of different SaaS applications. Each one has a different console. Each one has a different way of doing authorization. So, misconfigurations are rampant and over-provisioning is rampant. And so it's, a much harder problem. And if you think about the developers, they have to reinvent the wheel. They have to basically build their access control system for each one of the microservices. And, rarely are they, kind of like designing exactly the same way. So adding or changing permissions in an application means touching every single corner of the application, which is just not a scalable, solution. And in a zero trust world where, the security of the application is moved from the environment to the application itself, these apps haven't kept up. So if you look at the number one, problem in the OWASP top 10 list, this is the set of security vulnerabilities for applications. Broken access control is number one on that list. So security teams are just, like banging their head against this problem. So as an industry, we've kind of dug ourselves into a really deep hole, and it was time to get ourselves out of it.
So how did you determine? It sounds like your open source project and what you've built has potentially many layers, right? I mean, it doesn't seem, it seems conceptually elegant, but not necessarily simple.
Yeah, so what we're trying to do is simplify all this. So today, if you want to go build fine-grained access control, you kind of have to go build a whole system on your own. You could try to pick up an open source project like, say, Open Policy Agent and build it yourself, but most of the people that we've talked to, most of our customers have said it's really, really hard to do. And so what we've done is we've taken OPA as a decision engine, so it's a great piece of open source, and we've added a set of built-in capabilities that allow you to answer questions like, does this user have this permission on this resource? And that's exceedingly hard to do with OPA by itself. Mm-hmm. So Topaz, as an open source project, kind of brings all these capabilities together and really vastly simplifies what, kind of building this fine-grained policy-based access control system would entail.
And then it sounds like it liberates developers who then can trust Topaz to answer what is to them the simple, uniform question: is this user allowed to do this thing
Exactly.
in this place
Exactly.
on this resource?
When you talk to developers, I want to build the next RBAC system, said no developer ever,
right?
It's like undifferentiated heavy lifting, critical to get right, very important part of the security, posture of your application, but, it really doesn't drive any differentiation for your app. And so that's why so many people want to find a partner, find an open source project that will help them do that, as opposed to have to go reinvent that wheel on their own.
So does it make sense? So this makes sense for developers. It simplifies their lives. It becomes a set of services that become available because an operator has deployed, as I understand it, a sidecar that performs the queries, and then an SDK, I assume, that accesses the sidecar?
Exactly.
Is that how it works?
So, you can deploy Topaz either as a microservice in your cloud or as a sidecar right next to each application pod. Okay. And, the DevOps team typically will handle the deployment, aspects of it. The developer, all they have to do is use one of our SDKs or call our gRPC or REST APIs directly, pass it the user context and the resource context, and Topaz does the rest. It'll basically evaluate that query, incorporating the user context and the resource context, and coming back with an answer. Does this user have this permission on this resource?
And so that sort of yes, no, accept, reject thing is primarily what the developer wants.
That's
but
right.
Potentially, do they also want, and I bet you handle this somehow, do they also want to explain to their end user why something may not be permitted?
Absolutely. And we basically have a pretty sophisticated system that can return you the abstract syntax tree for the query and how it was evaluated and why it was evaluated, yes or no, so to speak. So you can basically go back and figure out, why this user wasn't allowed or why this user was allowed. And you could go build, things like anomaly detection over it. Let's say that you would be you're in the engineering group, and somehow the system registered in its decision logs that you had, write access to Salesforce. That doesn't compute, because most engineers don't, right? So it would actually have a complete log of the policy that allowed that and the data that was passed to it, and you could basically identify misconfigurations that way. Having this foundation allows you to go build very sophisticated, capabilities on top.
And then this lets you go much further than a typical RBAC system, right? I mean, I was hearing tell that it was possible to create complex conditional assertions for evaluation, like this person would normally have XYZ permissions, but they're in a location where we have temporarily chosen to disallow.
That's right.
That.
Yeah.
So
that's called attribute-based access control.
Okay.
And it was kind of gaining momentum in the mid to late 2000s and into the 2010s. And the idea there was that rather than just have, all the users assigned roles, that led to what's called role explosion, right? So you have, almost as many roles as there are users in the system. So the kind of next generation of access control was really about attributes. Writing rules like, if you're in this department, if your title is this, then, compute an allowed decision. And you could also incorporate environmental attributes like time of day or, geographic location or network, like the type of network you are connected to, or production versus development environment. So you can combine all these things together, roles, relationships, and attributes to build pretty sophisticated authorization policies. So we start super simple, but we allow you to, the simple things easy, the complex things possible. That's our philosophy.
And then Topaz also reports on all this, right?
Yes.
It logs it logs the transactions and decisions it makes in a recoverable way.
Exactly.
Presumably the operators, or anybody I suppose, with proper authorization can reconstruct the circumstances surrounding a particular decision.
That's exactly right.
Audit, backtrace.
Mm-hmm. Yep. So audit trails for compliance and forensics purposes. Compliance pretty obvious. Auditors want to know, who had access to what. Forensics, I would say, these days it's not if you have a breach, it's when. And when you do have a breach, you want to know what that user was able to do.
Yep.
And just having a log of the login isn't enough, So all you know is that they logged into that application. What you really want to know is what they did and what they had access to. And so a fine-grained decision log allows you to do that. And Topaz out of the box gives you fine-grained decision logs.
Seems like very powerful stuff.
Thank you.
And this can in principle run, this is native to Kubernetes. It can run in multiple configurations.
Yep.
It sounds like pretty much any cluster.
That's right. So we basically just package it as a container image. And so you can run as a sidecar, you can run as a microservice. We have a hosted version that runs in our cloud. So there's a lot of different ways of being able to use that technology and package it, so that you can get the most value out of it as a customer.
Hosted version is interesting. I imagine that it's useful to separate this functionality from the material reality of an instantiated cluster, for example, in many situations, so that it becomes portable, right?
Yeah. So for our hosted authorizer, typically our developers in our ecosystem use it for dev test. So it's, you don't have to stand anything up. We have one automatically for you. You don't have to ask your operations team to go deploy this thing. So you could basically develop, immediately. You can hit the ground running. But when that gets deployed into production, you want that authorization component to run as close to the application as possible. Mm-hmm. So, lowest latency, highest availability to the application.
Well, of course, because you're authorizing and authenticating literally every transaction.
Every transaction,
right.
Exactly.
It's a zero-trust architecture.
That's right.
Very slick. Mm-hmm. Well, thank you very much for talking to me.
Absolutely. It's a pleasure.
I think that was at least as good as your colleague.
Thank you.
In several dimensions more informative. So
thank you so much.